Okay, let's zip through some of these. So this first one, I didn't put, you'll notice I didn't put any of the horribly complex problems on. Just more basic kind of resolving forces into orthogonal components kinds of problems. So two ropes pull on a ring, one exerts this force at this angle, the other exerts this force at this angle relative to the positive x-axis, right? And all we want to do is we're going to really, this is kind of, in a way this is pretty good because it's asking you, it's kind of leading you through the solution, right? You're going to have to figure out what's the resultant force, has a magnitude of what, at what angle. And then the second part is a gimme if you get the first part. We'll talk about why when we get there. First, let's just figure out what the resultant is of those two forces, right? So our free body diagram would just look like, it's just going to look like this. So if there's the xy plane, we've got this force, this will be a red one, 42.4 newtons at 107 degrees. Well, if that's 90, isn't that just going to be kind of a little more than 90-ish? Doesn't have to be perfect, but so it's going to look like this. We've got a magnitude of 42.4, and if that's 107, I'm going to use the acute angle instead. I'm going to use this angle. So if that's 107 up to there, what's this little angle there going to be?
17.
No? I mean, well, that one right there, I'm going to use this one down here.
Okay. Well,
Either one would work, it'd be fine.
17 is here.
73, exactly. Yeah, it's just got to add up to 180, doesn't it? Everybody see that? So that's 73 right there, okay? Let's make this one blue. And so this is going at 35 newtons at 249 degrees. Well, let's see, that would be 90, 180, 270. So it's a little less than 270, right? So it's going to be pointing down kind of, you know, just say like that. So let's figure out what this angle then is. If this is 180 to there, I could just subtract 180 from that and get what? 69 degrees? So this one's 69 degrees. And the magnitude is 35.0. Is everybody okay with that? Right. Yeah, this looks like the boat problems. Yeah, from before, right? And that's really all we're going to do. We want to resolve this into some, you know, resultant vector, right? And so this is one where we could just make the tables. Okay, so we're going to break up this red vector into. So we're going to trade that one for some components. We'll trade those for, if this is the angle we're using, and we could have used that angle, it would have been fine, right? But if we're using this angle, we're going to break it into a horizontal component and a vertical component, right? And let's think about what those are going to be. So the horizontal component is going to involve the magnitude times which trig function? It'll be cosine, isn't it? Because there's our angle, and the horizontal component is the one that's adjacent to, right? So if we make our little table then, remember this table, right? We get a bunch of these. So we'll call that V1. How about, that's the red one. The X component, the magnitude is 42.4, you guys told me cosine theta, so cosine 73, right? Okay. 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 Good. What's positive or negative?
Negative.
How come?
Going to the left.
It's going to the left. So it's negative, right? It's going to the negative. We're going to assume this is going to be the positive x direction, that's the positive y direction, right? Okay, what about the y component? What's that going to be? It's going to be positive, good. 42.4 sine 73, because it's going to be the opposite of the angle, right? And that one's positive because it's pointing in the positive y direction, okay? We pause there. Questions? Is that making sense? Okay. All right, so then the blue one, That's 35. So we gotta break this into components. Now, what are the signs of those components gonna be? What the x component's gonna be? And the y component's gonna be? Negative. Okay, so we already know what we're gonna do. So we're gonna do negative, the magnitude is 35.0. That's our angle. So the horizontal component is adjacent or opposite? Or the horizontal component, yeah. Adjacent, so that'd be a cosine, wouldn't it? Cosine of 69 degrees. Okay, and then we said this was negative, it's going down. So that's gonna be the magnitude of the whole thing, which is 35.0 sine 69, right? And then now all we've gotta do is just, this becomes a calculator issue, right? Now we know that our resultant is gonna have that number for its x component, so let's just pull up the calculator. Okay, and so we get negative 42.4 cosine 73 minus 35 sine, cosine. Cosine 69, right? So there's the number we get. That's going to be our x component, right? It's going to be the one that is, we're going to use the calculator number, but it's roughly, so I'll just say, so it's the one that's approximately equal to negative 25, right? Okay, let's look on the other side. About over here. So now we've got, if we add the y's up, remember the little trick we can do? I can just go up and grab that previous computation, and then I hit second left and scoot all the way over. I'm going to go ahead and delete that because it's positive. And then I just have to go over and change the cosine to a sine, right? Remember this trick? Then subtract 35. I just want to make that a sine. And so there's that's the one that's about roughly 7.9, okay? So then now if we want to make a picture out of this, right now all we got to do is just rebuild this vector, right? So there's the xy plane. So our x component is going to be negative 25. So we're going to go back in this direction about negative 25. And we've got the calculator number stored. We're going to go up in the y direction about 7.9. So there's our result, right? How are we going to get the magnitude? 7.9 squared, square root of 7.9 squared plus 25 squared, calculator numbers, right? And then if I want to get the angle, and I'm not going to make that, I shouldn't really write that as a negative 25. I should just write it as 25 in that direction, right? That just tells me the direction. And then I would just do arctangent, wouldn't I? To get this angle of theta, it's arctangent is 7.9 over 25. And then I would just, if I want to know what this whole angle is, I could just subtract that from 180, right? Okay, we'll pick this up. We'll keep going with this tomorrow.
Are we going to be ever this year working with